Hour, your weekly interactive math reviews for Math 1314 and 1324, presented by Yvette Chuca, Ruben Carrizales, and Albert Isasi. This session will be recorded so that you may come back to it later if you need, and so others who may have missed it can come over and watch it later. Now, thank you. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we'll be sharing today. Without further ado, here is Yvette Chuca.
Hello, everyone. Happy Friday to everyone. They will be posting the link for Math 1324 for those of you that need to join that session. But for today in 1314, we're going to cover examples from section 2.1 and 2.2. So this is actually one of my favorite chapters, and so I hope that you all will feel the same way after seeing everything that is in chapter 2. So our main focus is going to be standard form of quadratic equations and some behaviors of our functions. At any time, if you would like to download the presentation, there is a download button on top where my mouse is at. You can, it's a box with an arrow pointing down. You can click on it and it will let you download the presentation. So in chapter 1, we've been talking a lot about linear functions. And one of the parent functions that we saw in section 1.6 was this quadratic function. And we know something's going to be quadratic if the highest power of x is a 2. And so here we have the general form f of x equals ax squared plus bx plus c. And this is an example of what the quadratic function will look like. We also said that the parent function is f of x equals x squared. And so the graph of a quadratic function is this U-shaped graph, which we call parabola. And we're going to go ahead and look at other characteristics of this graph. And so again, as I mentioned earlier, this form is called your general form. And then we can also write it as a standard form. And so if we look at these two graphs, one is opening up and one is opening down. And so let's look at some of these features. So if a is greater than 0, so that's going to be the coefficient in front of x squared. If it's greater than 0, then your graph is going to open upward. If it's less than 0, then the graph is going to open downward. Okay. We also have here on the left side, the bottom part of your parabola is going to be our vertex. And so the vertex can be found using this formula here. And we say that it has a minimum, or it's going to have a, let me ask you this quick question. On the right side, do you guys see a graph, or is it just my screen that doesn't see the graph? Anybody? You see the graph? Okay. All right. So let me log in to this session, but I'm going to log in on my other computer just so that we can, because my computer is only showing one graph, or my laptop is showing one graph, but it might be that my computer, yeah, no. So let's maybe if stop sharing and then let me see, let me upload it again. Okay, let's upload it again. And just to make sure. Okay, let's see, right now we have two graphs. And that's interesting. So I'm not sure why the second graph is not appearing, but we'll continue. If you can see it, that's great. For me, I don't see it, but it's okay. So let me use my pen just really quick. And hopefully the rest of the presentation is okay.
Miss Chuka, I don't
Yes,
know if this is right, but on the chat, they're adding like a link. I don't know if we need to do that. Like a separate link to join. I'm not sure why.
I think it's for the link is for 1324.
Oh, okay, okay. I thought maybe that
Yeah,
was the issue that we couldn't see the other
yeah. No,
guy.
I'm not sure why it's doing that because it was on the original file, but it's okay.
Okay.
So here, if the parabola is opening downward, that means that A is going to be less than 0. And this point here is our vertex, which is going to be represented by H and K. And we'll talk about those in a little bit more detail in a second. Okay, so this green line that we have here on the left side of the graph, this green line is called the axis of symmetry. And this line is always going to be found by looking at the x coordinate of your parabola, of your vertex. Okay, so if we have a parabola going down, it's still going to have that axis of symmetry as well. And the axis of symmetry, if it's in this form, is going to be at x equals h, which is still the x coordinate of your vertex. Okay, so one of the things that you're going to be asked to do in your assignments is to go from this general form to a standard form. And so we want to go from this form to this form. Another thing is if we have this standard form, the vertex can be found by looking at the h and the k. So if you have a minus h, you're going to have the vertex is going to be a positive h, and then we're going to keep the sign of k. So let's look at an example. It says determine the vertex. So for this example, it's already in standard form. So this equation looks like this equation. So we can get the vertex. Here we have a +1 and this is a -1. So what we want to do is we want to get the opposite of what we see in the parentheses. So the opposite of +1 is -1. And then we want to keep the sign of the outside number, which is 12 in this case. So that's going to be your vertex. Okay. So in order to go from, let me go back, from this form to this form, then we can use a method called completing the square. And so that's what we're going to do next here. And I have about 3 examples that we can look at so that we can get the steps um, down so that we can do these problems. So the first thing you want to do is you want to group the x terms together. So that's going to be your fx, your 4x squared and your 8x. We're going to group them together. And then we're going to factor out any coefficients of x squared that is not a 1. So if we look at the x squared, the number in front, if it's not a 1, we're going to have to factor out that number. And so it would look something like this. So here I have my 4x squared and 8x. I'm going to group these together. So by grouping, I'm going to put parentheses here just to kind of separate them from the 16. And I need to factor out that 4. So to factor out the 4, I'm going to bring it out to the front. And so if I take this 4 out, then I'm left with x squared. And if I take this 8, if I take 4 out of this 8, what's really happening is you're just dividing by 4. So 8 divided by 4 is going to be 2. And so here we have 4 times x squared would have been 4x squared. 4 times 2x is going to be that 8x. Okay, so if you're having a hard time factoring out a number, then just remember you can divide it by that factor and it's going to give you your answer here. So now that we've factored out the 4, now we can proceed to the next step. So the next step is going to be to take half of b. B is always going to be the number that's in front of x. In our example, b is going to be 2. So half of 2 is going to be 1. Okay, so that's your second step, and then you're going to square it. So if we square the 1, 1 squared is going to be 1. So let me repeat this step again. So after you factor out your number, you're going to take half of b, in this case 2, and 2 divided by 2 is 1. Then we're going to square it. Okay, then we can go to the next step. The next step is to add and subtract that step 2. So after you square your answer, you're going to add it and subtract it into that parentheses. Okay. Step 4 is we don't want to have this number that we subtracted. We want to take it out. We want to factor it out. So when you factor it out, you need to be careful. When you factor it out, we have to multiply it by whatever number is in the front. So in this case, we have a 4. So 4 times -1 is going to give us a -4. So this answer, -4, we're going to go ahead and include it with the 16. Okay. So now we have 16 minus 4 is going to give us 12. And this +1 just stayed there in the parentheses. Okay. All right. So we're going to continue. So by doing these steps, notice what's going to happen in that parentheses. This parentheses, we're going to be able to factor it into two like factors. So x squared plus 2x plus 1 factors as x plus 1 times x plus 1. Okay. And since they're the same, we can write them as x plus 1 squared. And so now our equation is written in standard form. So from here, we can get the vertex. So the vertex for this example, again, if you have a +1, we use the opposite, which is -1, and then we have our 12. Okay. So as I mentioned earlier, I do have a few of these examples so that we can get used to the steps. Okay, so let's try this one. At any time, if you have a question, just let us know. So here, again, the first thing, check your x squared. Do you have a 1? Yes, we have a 1. So that means that we can move on to the next step. Okay, so I'm going to combine, or I'm going to put together the x squared and 2x in parentheses. And I'm going to go to the next step, which is to take half of b. In this case, my b is 2. So half of 2 is going to be 1. And then we're going to square it. So 1 squared is equal to 1. So I'm going to take this result and I'm going to add it and subtract it into my parentheses. So my 1, I'm going to add it and subtract it. Our next step is we want to remove the -1. So if I take this -1 out, I have to make sure that there isn't a number in the front. So here I don't have a number, I just have 1. So 1 times the -1 that I bring out is just going to be -1. And then I can add it to the +1. And 1 plus -1 would be 0. And x squared plus 2x plus 1 can factor out as x plus 1 times x plus 1. And so since I have the same factors, then we have x plus 1 squared. So from here, we could get the vertex. Again, the parentheses, you want to take the opposite, which is -1. And then we have no k. So our k is going to be 0. The axis of symmetry is always going to be that x coordinate. In this case, x equals -1 would be my axis of symmetry. Okay, let's try another one. So here we have 2x squared plus 8x plus 7. So the first thing is we want to rewrite 2x squared plus 8x in parentheses. And so I went ahead and I grouped them here together. And now you want to ask yourself, is there a number in front of x squared other than 1? And there is a number, 2. So we're going to have to factor out the 2 from the parentheses. So if I factor out my 2, then I'm left with x squared here. And then 8 divided by 2 would give me the 4. And you can check your work. 2 times x squared is 2x squared. 2 times 4 is going to be 8x. Okay. So next, we're going to take half of b. My b here is 4. So half of 4 is going to be 2. And then we're going to square it. So 2 squared is going to be 4. And so next, we want to take that and we're going to add it into this parentheses here. So I'm going to add my 4 and I'm going to subtract my 4. So you might be asking yourself, well, why are we adding and subtracting it in there? Well, 4 minus 4 is going to be 0. So we're not really changing the problem because we're just adding 0. Okay, if you only added the 4, then now you're changing the entire problem. So it's important to add it and subtract it. But once we have it in the parentheses, then we want to remove this negative 4. So I'm going to bring this negative 4 out. But before I can do that, I'm going to have to do what? We're going to have to multiply by this 2 since we have a number out here. So 2 times negative 4 is going to be our negative 8. Okay, now we can simplify. So negative 8 plus 7 is going to give me negative 1. And x squared plus 4x plus 4 is going to be factored as x plus 2 and x plus 2. So I have a shortcut here because sometimes right now we're getting perfect numbers, right? No fractions or anything. But sometimes you might end up with some fractions. And so there is a shortcut here that I want to highlight for you. So this number that we're using here is always going to be the number you get. So this should have been, okay, yeah, after we squared it, that's okay, that's 4. So whenever you take half of this number, we got 2. And so this half number is what goes in here. Okay, so if you keep that in mind, then sometimes when you have a fraction, that's going to be helpful. Okay, all right, so let's continue. So now that these are the same, I can put them together. I can rewrite the problem as x plus 2 and x plus 2. I can write it as x plus 2 squared. And so now my vertex is going to be the opposite of my plus 2, which is negative 2. And then I have my negative 1 for my k. My axis of symmetry is always the x coordinate of the vertex. In this case, x is going to be negative 2. Okay, so let's look at this one. Write the quadratic function in standard form and identify the vertex. Okay, so this one it's a little bit different, but the first step is to group the x squared terms together, or the x's together. So we have 5x squared plus 15x. Second question is, do you have a number other than 1 in front of x squared? The answer is yes. So we're going to have to factor it out. Okay. So to factor it out, you're just dividing 5 by 5 and 15 divided by 5. So if we bring it outside, then we're left with x squared, and 5 times 3 is going to be this 15. So second step, take half of 3. So if we take half of 3, we get 3 halves, and then we're going to have to square it. So 3 halves squared is 3 halves times 3 halves, which would be 9/4. Okay. So what do we do with our result here? Now we're going to add and subtract into the parentheses. So I have my plus 9/4 and subtract 9/4. Okay, any questions? All right. So now we want to get rid of this minus 9/4. So I'm going to factor it out. But when I factor it out, what do I have to do? I'm going to have to multiply it times the 5. Okay, so let me just put a circle here so we don't forget. So I'm going to have to multiply the 5 times the negative 9/4. And so that's going to give us, and I have it down here, so negative 9/4 times 5 is going to be negative 45/4. Okay, so let me close that out. So I have it here, my negative 45/4, and then I still have this negative 5. So eventually we're going to go ahead and add these together. But let's work with the parentheses first. So you have x squared plus 3x plus 9/4. Since I have a fraction here, it might not be as easy to factor it out. But if you use the trick that I mentioned earlier, this number here is always going to be the number you get when you take half of b. So when we had 3, we took half of it. We ended up with 3/2, and then we have our 3/2. So we're going to have x plus 3/2 and x plus 3/2. On this side, we need to add negative 5 and negative 45/4. So common denominator would be 4. 5 times 4 is 20. So now I can go ahead and combine those. So negative 20 minus 45, negative 65/4. Okay, so x plus 3/2, we have 2 of them. We can write it as squared. And so from there, we're going to have our vertex. So we take the opposite of this. So we get negative 3/2. And then we have our k, negative 65/4. My axis of symmetry is going to be the x coordinate of x equals negative 3/2. Okay, so this is how we would change the general form of an equation into the standard form. And by doing that, it helps us to identify the vertex. Okay, any questions on that part? And then again, if you end up with a fraction here, just remember you can look at what the number was when you took half of it, and that's going to be what your factors are. Okay, so let's continue. So now I have a graph. One of the questions or one of the topics in section 2.1 is to write the equation of this parabola. Okay, so some of the things that you need in order to do that is going to be to, you're going to need at least one additional point, and then we're going to take the vertex from our graph. In this case, it's -1 and -1. And of course, always remember your standard form. So when you're reading the instructions, write the standard form. As soon as I see that, I always like to write it down here because I'm probably going to have to use it in some way. Okay, so let's see what information we have. So the vertex is going to be -1 and -1. So I'm going to write it here. And at least one additional point. So you can use any point you want, but you want to make sure you use a point that you know for sure is the coordinates. So this point is 0, 0, or you could have used -2 and 0. This point here would have not been good because I don't really know the exact number for that. So I'm just going to stick with the 0, 0. And now all we have to do is plug in this information, these 2 points, into the standard form. And what we're going to be solving for is a. Okay, so here's my standard form. F of x is equal to a. X is going to be 0 from our point, so I plug it in. Minus h. H is -1. So I have my -1 here. And then k is -1. So if we simplify, negative, negative is going to be a positive. So 0 plus 1 is going to be 1. And if we square it, we're still going to get 1. And so we have a1 minus 1. So I'm going to add 1 to both sides. So I'm going to end up with 1 is equal to a times 1. If I want to solve for a, I can divide by 1. So I get a is equal to 1. Okay, so why is this important? Well, now you know what a is, you know your vertex, so we can plug it in to the standard form. So here's a, here's my vertex, and negative, negative is +1, so that's going to be our equation. Okay, So you might have been thinking to yourself, well, I could have gotten the equation just by doing what we did in 1.6. So remember in 1.6, we had the parent function, which is right here. This is the parent function. And then if we wanted to find this equation, we said that we're going to move to the left, right? So to move to the left, that's your plus 1 right here. And then we're going to move down. And to move down, that's your minus 1. But by us doing that, though, we don't know what the a is going to be. So in this case, what 1 is. Remember that number is going to determine if your graph is going to get more narrow or wider. Okay, so this just gives us a more accurate way of finding the actual equation. Okay, so let's go to another example. Here I don't have a graph, but they give me the two things that I need. So again, it says write the standard form. So we're going to write the standard form. So here's my standard form. And then they give me the vertex. So this is my H, this is my K, and then this is my other point, which I can call X and Y. So I'm going to plug in that information. So here I have Y is 3. So I'm going to put 3 is equal to A we don't know, X is 0, minus our H, which is negative 3, and our K, which is negative 15. If we simplify, we get negative negative is positive 3, 0 plus 3 is 3, and if we square the 3, we get a 9. So I'm going to add 15 to the both sides, so I get 15 plus 3 is 18, and then we get is equal to A9. So divide by 9, and we get A is equal to 2. So since A is 2, we can now come to the equation, and I'm going to replace my A with the number 2. And then, of course, I'm going to put my H and K. So my final answer would be f of x is equal to 2 times x plus 3 squared minus 15. Okay, so again, the reason we have to do this method is so that we can really identify what A is going to be in this case. Okay, so our x-intercepts. So these points here where the graph crosses the x-axis have different names, right? So you might hear us say x-intercepts. You might hear your instructor say zeros, roots, or solutions, but they all refer back to this point. And these 2 points are special. That's when y is equal to 0. Okay. So whenever you want to find the x-intercepts, we always let y equal 0 and solve for x. Now to solve for them, there's different ways you can do that. One, you can use the square root property, but keep in mind that the square root property, you can't always use it. We can try to factor, but we can't always factor. And then we can use the quadratic formula. This one, you can always use the quadratic formula. So something I like telling my students is, if you try factoring, give yourself a minute. If you can't figure out what the factors are, then go to a different method. In that case, the quadratic formula. Sometimes you might not have a x-intercepts either. Okay. Is there a question? Okay, so let's look at some examples. So here we have the methods for solving quadratic equations. I'm going to look at the square root property first. We'll do 2 examples. Okay. First step, if it says to solve, that means that they want you to find the x-intercepts or the solutions. And so to do that, we first have to let f of x equal to 0. So remember, f of x is your y. So we get 0 is equal to our equation. And then we're going to, in order to use the square root property, your x squared term has to be by itself. So we're going to add 4 on both sides. And we get 4 is equal to x squared. So now we can use the square root property, which says I can take the square root on both sides. And so we have the square root of x squared and the square root of 4. Well, the square root and the square are going to become 1, or some of us like to say they cancel. So we get x, and then the square root of 4 is plus or minus 2. And so this is going to be your two zeros. X is equal to 2, and x is equal to negative 1. So if you were to draw this graph, that's where the graph crosses the x-axis. And so let's look at example 2. So here we have 3 times x minus 4 squared minus 27. In order for us to take the square root like we did here, whatever's being squared has to be by itself. So we're going to have to get rid of this negative 27, and we're going to also have to get rid of this 3. Okay, but first we need to make sure that we set the equation equal to 0. Now I'm going to add 27 on both sides. So we get 27 is equal to 3 times x minus 4 squared, and I'm going to divide by 3. So 27 divided by 3 is 9. 3 divided by 3 is 1. Now the term that is being squared is by itself. So we can take the square root. The square root and the power of 2 are going to become 1, or they cancel. So we get x minus 4, and the square root of 9 is plus or minus 3. So now we can add 4 on both sides. So we get 4 plus or minus 3 is equal to x. So there's going to be two solutions. X is equal to 4 plus 3, which is 7. And x is equal to 4 minus 3, which is equal to 1. So don't forget the reason we're doing this, how it relates back to the graph, is going to be these 2 points where the graph is crossing your x-axis. Okay. So that is one way to solve these quadratic equations. The next way is factoring. And in fact, if you struggle with factoring, I'm going to post a link. You can go watch this video, and it's Friday Happy Math Hour, and all it talks about is how to factor. And so that's a video from Mr. Isasi that he did about 2 weeks ago. So if you want to review your factoring, then you can watch that video. So here for factoring, again, the first step, let y equal to 0. And then here we have x squared minus x minus 6. So you want to think of two numbers that you can multiply to get 6, but when you add or subtract will give you a negative 1. And so negative 3 times 2 will give you a negative 6. And if you subtract negative 3 and 2, you're going to get this negative 1. And so we can set each of these factors equal to 0. So using the 0 product property. So x minus 3 is equal to 0. Solve for x, we get x equals 3. X plus 2 equals 0. Solve for x, we get x equals negative 2. So that is using factoring. Now, if you're not sure if it factors or you can't find the factors, then we can use the quadratic formula, which is negative b plus or minus b squared minus 4ac divided by 2a. And remember that a is always the number in front of x squared, b is the number in front of x, and c is your constant. So in this problem, my a is 1, my b is negative 2, and my c is negative 8. So I'm going to plot those numbers, plug them in. So we get minus negative b, which is negative 2, plus or minus b squared, which is negative 2 squared, minus 4 times a is 1, times c, which is negative 8, divided by 2 times a. So we simplify. Negative 2 squared is 4. Negative 4 times 1 is negative 4 times negative 8, positive 32. Keep simplifying. 4 plus 32 is 36. And the square root of 36 is 6. If I divide 2 divided by 2, I get 1. And 6 divided by 2 is 3. So my two answers will be x is equal to 1 plus 3, which is 4, and x is equal to 1 minus 3, which is negative 2. And so those would be my zeros. Okay. Now in section 2.2, we're going to look at other polynomials, not just the quadratics, but what if the highest exponent was a 3 or a 4 or something greater, okay? So one of the things is, what is a polynomial? A polynomial is a function that when you graph it has a continuous graph, okay? So this is continuous. You can draw it without lifting your pencil up. If you look at this one, this is not a polynomial because in order to draw it, I have to lift my pencil up to draw the second part, okay? That's one of the criterias. The other one is the polynomials have rounded turns, okay? And they have no sharp turns. So if it has a sharp turn, it's not going to be a polynomial. Okay. One of the things that we want to be able to do is identify how these polynomials behave, and we at the left side and the right side, and we call that the end behavior. Okay. And the reason we're going to do this because our main goal in the next few sections is going to be able to graph these. And so this is one of the steps that is going to help us figure that out. So if you look in your textbook, they have listed all the behaviors. So there's some long sentences there. Something I tell my classes is we already know what these graphs pretty much, right? We know what x squared looks like. This is the parent function. If it has a negative, we know it's going to open down. I have my cubic function, which is my parent function. It looks like this. And if I have a negative, then it's going to look like this one. So if you can remember these 4 graphs, then you don't have to memorize those long sentences, right? And so, and you'll see why here in a little bit. So one of the things, in order to determine the end behavior, we're going to be looking at the degree of the polynomial. So the degree of a polynomial is going to be your highest number of your polynomial. So like if I had this example, let me just give you another example here really quick. Let's say we had f of x is equal to x to the 4th minus 3x cubed plus x. Then the degree of this would be 4 because that's the highest exponent. Sometimes they give it to us out of order. What if we have x cubed plus x to the 5th minus 3? Let's say we have g of x. Then the degree is going to be 5 because that's the largest exponent. Okay. So that's what I mean by degree. And so what we want to look at is whether the degree is even or whether the degree is odd. Okay, so 2 is even. And then the other thing we're going to look at is the leading coefficient. In fact, this is called the leading coefficient test. The leading coefficient is going to be the number that's in front of the term with the highest exponent. So here, the number in front of x squared is 1. And for this, we're going to decide, is it positive or is it negative? Okay. All right. So let's continue. If this is the case, then the behavior, notice it's rising to the left and it's rising to the right. Okay. Let's look at the second one. So here the degree is even because it's 2. And I have a -1 in front of the leading coefficient. The leading coefficient is -1. So here I have my -1. So the behavior is it's falling to the left and it's falling to the right. Okay. So if we look at the next one, we're going to have f of x equals x cubed. So my degree there is, this should be a 3, this should be a 3, okay guys, this is a 3 here. So the degree is 3, so that's odd. And then my leading coefficient is 1, and that's positive. If that happens, then we say that the behavior rises to the right and it falls to the left. And then the last one, this is also a 3. So my degree is 3, that's odd, and my leading coefficient is -1. And so that behavior is going to be rises to the left, falls to the right. How can we use this information? Let me give you some examples. Okay, so here we have describe the left hand and right hand behavior. So the first one is f of x is 3x to the 8th plus 7x squared minus 2x to the 5th plus 4x plus 100. So first we need to decide what is the degree. So any takers on what the degree is for this one? Is it 8, 2, 5, or 1? What do you guys think? 8, 2, 5, or 1? So the degree for this polynomial is going to be 8. Okay. So then you want to ask yourself, is 8 even or is it odd? Okay, so 8 is going to be even. So that means that right now my choices are this graph or this graph. And then the number in front of x to the 8 is positive. So now that means that the behavior of this graph is going to be like this one here. So my answer would be that the graph will rise to the right and it's going to rise to the left. So it's going to have this behavior that we see for the parent function x squared. Okay, let's try another one. So here my degree is 3, which is odd. That means my behavior is like this one or this one. And then the number in front of it is negative. So that means that I'm going to be using the same behavior. So my answer would be the graph will rise left and fall right. Okay, let's look at the next one. So here my degree is, so I have a 6 here, but I need to check all of them. So I have 6, 5, and 8. So my degree is 8. And that's an even number. So that means it's gonna behave like these first two. Okay. And then in front of it is a -4. So since it's a -4, that means that the behavior is gonna be like my second graph. So my answer is the graph will fall right and it's gonna fall left. Okay. Now be careful if your polynomial is not completely simplified. In this example, you have a -2 in the front times x cubed plus 9x squared plus 8. So you want to make sure that if you were to multiply this -2 into the parentheses, it could change your answer. Okay, not all the time, but it could. So if I multiply -2 times x cubed, then my degree is still going to be 3, and my leading coefficient is actually -2. And so that graph is going to behave like our last graph. So we say that the graph rises left and falls right. In a little bit, we'll put it all together. Another thing that we want to look at is when or how do we know if a graph is going to cross like it's doing here? Or when do we know if the graph is going to touch the x-axis and turn around? So notice here, this one touches and turns, but this one just goes right through it, right through the x-axis. And the same here. This one goes, crosses the x-axis. This one touches the x-axis and then it turns. So how do we know when that happens? And that happens, or the way we're going to figure that out is by looking at the zeros and checking to see if they repeat themselves. Okay, so if we look at the first one, we have x minus 2, x plus 1, x minus 4. If I found the zeros for that, one zero is x equals 2. Another one would be x equals -1 and x equals 4. So each of these zeros is only appearing one time. And the number 1 is odd. So it appears an odd number of times. If that happens, then your graph is going to cross. But let's look at this one. The zeros here are x equals -2, which is right here. And they also tell me that we have x equals 2, which is right here. And they also tell us we have another x equals -2, which is right here. So this one has x equals -2 twice, okay? Since the x equals -2 repeated an even number of times, then the graph is going to cross, it's going to touch and turn, okay? So if it repeats an even number of times, it's going to touch and turn. Let's look at this one here. We have a negative x equals 0, which is right here, x equals 2, x equals -2, and they give me an x equals 0. Since 0 appears twice, then it's going to touch and turn. At x equals 2, 2 appears one time, so it's going to cross. And at x equals -2, the graph is going to cross. If something repeated 3 times, then the graph would cross because it's an odd number of times that it repeated. Okay, so what we call that is the multiplicity of zeros, is how many times the graph is going to appear, okay? And again, I tell my students, if you don't want to remember all the rules, if you just remember these two graphs, you can figure out what the answers are. So in x squared, if we solve for 0, we get x is equal to 0 and x is equal to 0, so it appears twice. That's why it's touching and turning. For x equals cube, we could write it as x times x times x. So that's going to be 3 zeros. Since it's an odd number of times that they repeat, it's just going to cross, okay? So find all the real zeros. So let's try some examples here and determine the multiplicity. So first, I recognize this is a quadratic equation, so I can use any quadratic methods. So I'm going to try to factor. So I need to set it equal to 0. And we're going to try to factor. So this would be x minus 1 times x minus 1. Set each factor equal to 0 and solve for x. So x minus 1 becomes x equals 1 and x equals 1. So that means that I have 2 zeros, but it's the same 0. So it's repeated twice. So we want to know, so we would say that the multiplicity of x equals 1 is 2 because it repeated twice, okay? Since it repeats twice, then the graph is going to touch and turn. Let's try another one. So here, t to the 4th minus t cubed minus 30t squared. So it says to find the zeros. So first, I need to set it equal to 0. And I'm going to ask myself, if I notice here, t4, t cubed, and t squared, they all have at least one t in common, or at least two t's in common. So I'm going to factor out a t squared. So t squared times t squared would give me t to the 4th. And t squared times t gives me t cubed. And then I factor out the t squared, so t squared times -30 is -30t squared. What I have left in the parentheses, it's quadratic. So I can either use the quadratic formula or I can try to factor. So here, this is going to factor as t minus 6 times t plus 5. And so I can set each of these equal to 0. So I have 0 equals t squared, 0 equals t minus 6, and 0 equals t plus 5. If I solve for t, if I take the square root of t on both sides, then I get t is equal to 0. And here I get t is equal to 6 and t is equal to -5. Be careful when you're looking at 0 equals t squared. If you take the square root, we have to be careful because here we actually get that 0 to repeat twice. So you have t squared is equal to 0. That's the same as t times t. That means we have t equals 0 and t equals 0. So the 0 is appearing twice. So we say that it has an even multiplicity of 2. And the other ones, 6 and 5, negative 5, they're both going to have an odd multiplicity because they only appear one time. Okay, so if you wanted to see the graph at t equals 6, it's crossing. At t equals 0, it touches and turns. And then you have at t equals 6, you have that it's going to cross. Okay, let's keep going. Now we're going to sketch, and I think this is my last example. So to sketch the graph, you need to identify the behavior. You need to find the zeros and identify the multiplicity and the y-intercept. And then you want to plot extra points. So first, let's look at the behavior. So you have a cube, okay, so that's odd, and the number in front of it is positive. So the behavior is going to be that the graph will rise to the right and fall left. The zeros, we set it equal to 0. I'm going to factor out an x squared. So I get x equals 0 and x equals 3. So x equals 0 has multiplicity of 2. So that's even. So that's going to touch and turn. And at x equals 3, it's going to cross. Find the y-intercept. To find the y-intercept, we let x equal 0. So we plug in 0, then we get the y-intercept is 0, 0. So let's put everything together. So I plot my zeros. So I have x equals 0 and x equals 3. Okay. Once you plot your zeros, then you want to apply your end behavior. So it says the graph will rise to the right. So with the pencil, I'm just going to make a sketch here. It's going to rise to the right, and then it's going to fall to the left. So I'm going to fall to the left here. But at x equals 0, the graph says to touch, right? So it's going to touch. So I'm going to know that it's touching here. And then at x equals 3, it's crossing. That's why my line kind of goes through it. But I need to know what's going on in between these two zeros. So that's where the additional points come into play. You could get points over here, but it's not going to be that helpful because this graph just keeps going. So the best points to get would be in between the zeros or where we have the gaps. So I'm going to use f of 1. So if I plug in 1 for my x's, then I get a negative 2. If I plug in a 2, I get a negative 4. And if you're not sure yet, then you can use 2.5. So if I plot those, then my graph will look something like this. And so that would be your sketch. Most of these on WebAssign are going to be multiple choice. So once you do it on paper, then you can check to see which one looks more like yours. And this is the actual computer graph, but it looks pretty close, right? And so that is how we would graph these examples of something that is higher than a 2. So this is a cubic function. And so that would be our answer. So I only have 7 minutes. So just as a reminder, if you want this presentation, there's a box with an arrow pointing down. If you click on it, it's going to let you download the presentation. If you want to see the video again, maybe you're not at section 2.2 yet, and you want to see it when you do get there, then they have been posting some links to the YouTube channel. So all of these are available on YouTube as well. So I'm going to pass it back over and hope to see you next week.
Thank you, Ms. Chuka, for your wonderful presentation. We do want to remind you all about your previously recorded sessions, which are available on YouTube playlist. Today's session will also be available on that playlist later on today. Also linked is a short survey to help us improve our TVE sessions. Please take time to fill out the survey. Before you leave, I want to share the TVE sessions that we will have next. We'll be back with a Happy Math Hour next week at 11, when Math 1314 will cover synthetic division and complex numbers. And Math 1324 will be covering solving exponential and logarithm equations. The student success will be giving a presentation on the Writing Center. At 1 p.m. today, we will also have student success presenting EPCC Foundation. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use the chat box or mic. We hope to see everyone again for Math Happy Hour next week. Thank you.